This video is brought to you by our amazing supporters over at Patreon. What makes a system good? Just like a platformer will be frustrating if it has bad jump controls, or a cinematic game will feel corny with bad voice acting, a systemic game will fall flat if its systems aren't engaging. So let's take a look at a few elements that can help systems stand out. Reliable randomness. When we talked about what systems do, we discussed the complementary relationship of calculable simulations and unexpected emergence. From a mechanical point of view, this can be viewed as hitting the sweet spot of randomness, being neither too predictable nor too chaotic. But that's easier said than done. Randomness keeps games interesting, but players will often complain about pure randomness because they cannot make an informed decision given the situation. Let's consider the simplified example of rolling a six-sided die. Our game is simply to guess the result. Rolling a single die is unpredictable, every side is equally likely, and it has a small possibility space, one of 6 values, so the randomness becomes uninteresting. We can remedy this, however, by adding what seems like more randomness, a second six-sided die. We have increased our range from 6 values to 11 possible values, but what's more interesting is the distribution of those values. Values in the center are much more likely, up to 6 times more likely, in fact, than the outliers. In fact, the 5 center values have a 2 in 3 chance of being rolled, meaning the outer 6 values have only a 1 in 3 chance. With this sort of curve, we're able to make more informed decisions. We can take this a step further with a third six-sided die. Now, we will roll 1 die first. Then we must try to predict the result, knowing that as our final step, we will roll the other 2 dice and only use the highest 2 values for the total. This further changes the curve of all possible values, and we can make an even more informed decision because we have prior knowledge before rolling the final dice. So, randomness is a good thing in systems, but that randomness should respond to outside forces so that we can get information about its behavior and make intelligent strategies. We can make our system even more dynamic with the second element of good systems, a smart use of loops. When talking about systems design, loops come in 2 varieties, positive feedback loops and negative feedback loops. Positive feedback loops are systems where running that system makes it easier to run the system again. Another oversimplified example. Imagine a system that requires 1 unit of commodity X in order to run. The system then produces 2 units of commodity X. For running the system once, you can now run the system twice. Even a system as simple as this can be found in use in games. Imagine an RPG where your party, at its current stats, hit points, skills, items, can participate in 1 combat before needing to go back to town to get healed. But by participating in that combat, they gain a level, which increases their stats, so now they can participate in 2 battles before needing to get healed. This double efficiency every run is probably too fast of a growth curve for most games, but tinkering with the numbers in this sort of a loop is how we get a sense of progress in our games. The flip side of this is the negative feedback loop, a system where running the system reduces your ability to run that system again. For instance, what if our system that takes 1x produces 1y instead? We have gained something from the system, but we now have a net loss of that original x, and so we have less that we can use to run the system again. This works in our RPG example as well. Each time we enter battle, our party loses hit points, uses up items, likely spends their magic or skill points. For every battle, we are less able to battle again before we need to go heal and restock. A good system will use both of these loops in tandem. We suffer short-term losses from negative feedback loops in an effort of building or running a larger positive feedback loop. In our XY loop, for example, our first system costs X but gains Y. We may have a second system that spends Y but produces more X than we started with. So we've added a step, but we've regained our positive feedback loop across these multiple systems. This can be expanded with additional commodities, upgrades to more efficient systems, or more direct loops that don't take as many steps. In board games, this is often called engine building, finding the most efficient combination of loops for the greatest gain. The last element I want to talk about has to do with how we approach the contents of our systems and our game world, and it's a philosophy of focusing on adjectives over nouns. What this means is that in a good system, no object is defined by its name. Rather, its traits make it function. An item called a sword that deals damage when the attack button is pressed is functional, but it is not systemic. If there's another item called spear that does the same thing, what is the difference between them? Instead, perhaps both of these are items of type weapon. They may both be melee weapons as well, although perhaps the spear can also be thrown. Sword may have traits like bladed and one-handed, while spear is pointed and two-handed. This not only helps us differentiate otherwise similar items, but it gives us a vocabulary we can use with other things as well. A lantern may be one-handed, a wood axe may be bladed, a rock can be thrown. This ability to mix and match makes systems more interconnected, leading to interesting emergent relationships. But that modularity relies upon systems driven by adjectives and very simple nouns, rather than hard-coding traits into each object separately. It also reduces the amount of work you need to do to define these relationships. Thinking in adjectives gives you a wide palette of options that you can use in your design, and that can interact in interesting ways. This is not an exhaustive list by any means. Good systems require a lot of work to get right, but using these three elements as a starting point, we can build systems that are dynamic, engaging, and even make our lives easier as designers. Another big factor in systemic design is working with a game that lends itself to these sorts of systems. Systems can be added to any game, much like RPG-style leveling has been added to many different game styles. But some games seem to really embrace their systems and make them shine as a feature of their design. And we'll talk about those in the next video. In the meantime, thanks for watching, and I'll see you next time.